In this exercise, we're given a line integral of type 1 to compute, but the curve C is described as the perimeter of a triangle. Let's sketch the triangle. O is the origin, that's this point, O. A is the point 0, 1, which means that y is 1, so that would be somewhere, let's say, here. And B is 1, 0, so that would be somewhere here. And then OAB, usually we take it in order. So from O to A, and then from A to B, and then finally from B back to O. So it's a closed path. And what we have to do is, since this is defined piecewise, is just take this and break it up into three separate integrals. So this integral of x plus y squared ds over the curve C, I'll just break it up. I'll first of all take the integral of the same thing along OA, and then I'll take the integral of the whatever it is along AB, and then the integral of whatever it is along BC. BO. We're going to need to parameterize each of these segments, so I'll just remind you of the formula for a parametrized segment. There's actually more than one. Previously, I used the formula that xy is equal to 1 minus t times the first point. Let's say the first point was x naught, y naught, and then t times the second point, whatever that is. Let's call it x1, y1. We're going to use this 3 times, once with with each of the 3 sides. There is a variation of this which is equivalent, which is sometimes I find more useful. Is just to say that this is x naught, y naught plus t times the difference of the two, x1 minus x naught, comma, y1 minus y naught. Sometimes I use this form, sometimes I use this form. Let me even repeat the xy. You know what? Let's work with the second form in this exercise. So I can now parameterize each of them. I forgot to add that in each of these cases, t goes from 0 to 1. Okay,